Hi folks. So in this video, I'm going to show a few things to factor that look a little more complicated. What I want you to be paying attention to is whether something is fully factored or not, whether you've gone far enough, whether there's any more to do or not. And that's something that's really hard to deal with, actually, really hard to understand whether you need to go further or not. So let's take a look at things. Maybe I can walk you through with these three examples, which are all, challenging. They're challenging to look at. They've got high exponents and all kinds of stuff going on. Let's take a look at the first one. So the first hint in factoring is always, always, always check for a GCF. I don't know if I've emphasized that enough in the videos, but GCF, first thing, GCF. So in this one, we definitely have a GCF, 3. And then if you think, hey, by the way, if you want to pause the video and try these, that would be a good idea. Pause the video and try these, see what you do, and then see what I do. That would be a good idea. So pause now. Okay, you're back. So first one, we have a greatest common factor. So greatest common factor of, looks like not only 3, but 3x squared. So I'm going to take a 3x squared out. To get back to 3x to the 6th, we need to multiply that by x to the 4th. This we need to multiply that by x squared. And this we need to multiply that by 1. Okay, now, that's x to the 4th and that's x squared. So we can think of this like a quadratic, except instead of having x and x to the squared, we have x to the 4th and x squared. So we would still have something like, still have a 3x squared out here. You still have something like x and x, except in order to get to x to the 4th, you have x squared. And if you have x squareds here and you have numbers here, you're still going to get x squared in the middle. Okay, so this is still set up like a quadratic, even though it's a 4th term polynomial or a 4th term trinomial. So it's still like a quadratic, but we have x squareds here instead. So let's see, is there anything that multiplies to 1 that also adds to 1? Well, 1 and 1 would add to 2. So there actually isn't. So we're done at this point. All right. So this would be considered, this part's considered prime, but we've factored out a greatest common factor and we're done. Okay. Now the next one, let's see what happens here. I'll use green. All right. So again, we have a greatest common factor to take out. So that's going to be x squared this time. So here we have x squared times x to the 4th plus 7x squared plus 10. Okay. Now, we're in the same situation we were a minute ago. We have this x squared on the outside, and we have x to the 4th, x squared, and a constant. So again, this is going to try to set up like the two binomials did above. Let's see what happens now. So x squared. So two things that multiply to x to the 4th are x squared and x squared. Two things that multiply to 10 that add to 7 are 5 and 2. And we have plus signs. So when we look at this, x squared times x squared is x to the 4th, 2 times x squared, and 5 times x squared becomes 7x squared, and 2 times 5 becomes 10. So we factored that. And now we have to look at these and see if we can factor these further. Well, these are sums of something. If you have two terms in a binomial and they're sums, we can't factor them. And there's an important aspect of that that's going to come up later when we go to graphing. This x squared plus something versus x squared minus something that are going to be very different from one another for a very particular reason that I hope that we can emphasize in chapter 9. But for right now, this seems done. There's no way to factor that further in the current type of factoring that we're doing. Okay, so those two are done. Now, the next one also is an x to the 6th. Also is a trinomial. Also has an x to the 4th and an x squared here. So once again, this one too has a greatest common factor of x squared. So x squared times x to the 4th minus 25x squared plus 144. Okay, so I'm going to scroll the page up here a little bit, the low tech sort of way. All right, here, x to the fourth, x squared, a constant. It's going to factor like a quadratic, but it's going to have x squareds in the first term. So x squared times, let's see, x squared, those are two things that multiply to x to the fourth. Then we need two things that multiply to 144 that add to negative 25. So since this is plus and this is minus, these are both negative signs. Two things that add to 144 that, or sorry, multiply to 144 that add to 25 are 12 and 12. No, 12 and 12 would be a 24 here. 16 and 9. 16 and 9. 16 times 9 is 144. 16 plus 9 is 25. Okay, now we're in the same position we were a minute ago here when we were done. But these are difference of squares. There's a minus sign here. There's a minus sign here. That's a perfect square. That's a perfect square. That's a perfect square. That's a perfect square. These are both difference of squares. They both need to still be factored more. So x squared. This first one is going to get factored. The second one, it's going to get factored. They're going to start with x's. Square root of 16 is 4. Difference of squares always creates conjugates. Square root of 9 is 3. Difference of squares always creates conjugates. And now we're done. And now we're done. All right, so this is where factoring is starting to get more advanced. We won't get more advanced than this in this class, I don't think. Although maybe we throw another variable in here. You know, maybe these wind up with a y in them, you know, which means these would wind up with a y squared, which means these would wind up with a y to the fourth and a y squared. I don't know, you know, there's a couple other things we could do, I guess. Factoring will get even more complicated in Algebra 2, but if you get kind of shallow understanding here, but a good understanding up to this stuff, you have a really, really good foundation for moving forward from where we are. So in the next chapter, we start to do equations. On the challenge page, there's an explanation of equations. So I'm not doing that as a video yet. I want to see what you do with zero product property. So read the challenge page. That is part of the homework at the top. There's some explanation of it. And then see what you do with that. I think a lot of you will figure it out. And certainly you're welcome to talk to each other about that and collaborate. That would be a great thing to do.